Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. In this video, I will explain about capacitance. So let's consider we have two conductor plate. So this is the first conductor plate and this is the second conductor plate. So this plate is separated by using a dielectric with a certain value of thickness for that kind of material. So the first conductor plate is connected to the positive terminal of the battery, and the second conductor plate is connected to the negative terminal of a battery. So because of this plate is connected to the positive terminal of the battery, so the positive charge will be accumulating into its surface. So similar what will happen in this surface of a conductor, because of this plate of conductor is connected to the negative terminal of the battery, so the negative charge will be accumulating it into its surface. Because of this charge is connected in the surface, so the value of this charge is represented by its surface charge density value. And because of we have different potential or different sign of charge, which is this side will be positive Q and this side will be negative Q, electric field intensity will be developed, and the direction of the electric field intensity is as shown in this figure. So the charge distributed will be distributed well on the conductor surface to maintain the value of electric field intensity on this surface of conductor is equal to 0, and with this occurrence, so basically we will have the electric potential at every point inside this conductor will be the same. As we have been learned before, so the general expression for the capacitance given by this equation, whereas the C is equal to Q divided by V. C is a capacitance, so Q is the value of the charge that accumulating in this surface of the conductor, and V is the value of different potential between this plate. So the unit of C is equal to coulomb per volt, or a unit of farad. Alright. So from the concept of a boundary condition, in the case of a conductor to dielectric, so we will have the tangential component for the electric field intensity and electric flux density is equal to 0. So however, for the normal component for those components will be equal to this formula, which is electric field intensity in a normal component is equal to rho s divided by epsilon of dielectric, and the electrical flux in this case inside the dielectric is equal to rho s. So by referring into this expression, so we can have that the normal component of an electric field intensity is equal to this expression. So whereas the normal component for the electric field intensity is equal to n cap dot with a vector of electric field intensity, and this value is equal to rho s divided by epsilon. So in this case, the epsilon value or electric permittivity value is the value that the dielectric has. So when we move this epsilon into this side of the equation, and then we are integrating, we perform surface integration process in this rho s, then we will have the value is equal to Q. Then we will have in the solution is given by this equation, whereas the surface integration of rho s dot ds is equal to surface integration of epsilon dielectric multiplied by n cap dot with the vector of E dot ds, and the solution for this operation is equal to q. So the end cap is also in direction for the surface. So we can rewrite this expression as below. So whereas we have surface integration of rho s dot ds is equal to surface integration of epsilon for dielectric multiplied by the vector of E dot with the vector of ds, and the result of this operation will be equal to a value of q, or the value of the charge. So at the same time, the potential difference if we are measuring from the conductor 1 to the conductor 2 is given by this expression. So whereas V is equal to V12, whereas the potential difference from the conductor 1 to the conductor 2 is equal to minus integration from P2 until P1 vector of E dot vector of dl, whereas the P1 in the point P2 are the 2 points at the conductor. Since we have the general expression for the capacitance is C is equal to Q divided by V, and by considering the two equations that we have been derived just now, so we will have the capacitance value in a field perspective can be calculated by using this expression, whereas the surface integration of epsilon E dot ds, so this one is a vector, so epsilon is the permittivity for the dielectric, so divided by minus integration of line vector of E dot vector of dl. So as shown in this equation, so the vector of E appear on the both numerator and denominator. So therefore, the value of the capacitance is always independent of the magnitude of the electric field intensity. So because of when we solving this equation, so the magnitude of vector of E will be eliminated. Because of that, basically the capacitance value is depend on the capacitor geometry, so either size, shape, and the position of a conductor, and as well as the value for the electric permittivity of the dielectric or epsilon dielectric. Alright, so let's say our dielectric that locate between our conductor is not a perfect dielectric. So whereas in this case, the sigma or the conductivity for dielectric is not equal to 0. So we might have a small value of conductivity in this case. So because of that, so we will have a small current flowing between those conductor, and at the same time, because of that, so we will have certain value of resistance appear on this particular of material, which is dielectric. As we have been derived before, so the expression that represent our resistance is equal to this equation. So whereas minus line integration of vector of E dot dl, so divided by surface integration of conductivity multiplied by the vector of the E and multiplied with the vector of surface. Then in the concept of capacitance, so we have what we call it as a time constant for the RC circuit. So whereas the time constant of RC can be calculated by using this equation, which is the resistance multiplied by the capacitance of the capacitor itself. By considering the expression that represent our resistance and the capacitance as we have been derived just now, so we can have that the equation that represent this time constant is equal to epsilon divided by sigma. So this is the permittivity of dielectric, so divided by the sigma. Sigma is the conductivity of the dielectric. Alright, so in order to understand this topic better, so let's look on one example. So in this example, so we need to find expression of C, which is capacitance, separated distance of D. So this is the value of the thickness for the dielectric, and the permittivity of the dielectric is equal to epsilon. And if the dielectric is quartz, find the breakdown voltage if the D, which is the separated distance or the thickness of the dielectric, is equal to 1 centimeter. Alright, so first let's assume that the conductor plate is placed on the XY plane, okay, by referring to the figure that I showed in the earlier of this video. So this figure. Alright, so firstly we assume that our conductor plate is placed on the XY plane. So this is our XY plane here. Alright, so this is our XY and this is our Z axis. So for the conductor 2, so the conductor on this side is placed on the Z is equal to 0, and our conductor 1, which is this conductor, is placed on Z is equal to D. So because of that, since our electric field intensity is flowing in this direction, which is the minus Z direction, so we will have the vector of E in a minus Z axis, or minus Z cap, and the general expression for the vector of E is equal to minus Z cap multiplied by E, whereas this E is equal to amplitude of this vector. Since we have the expression that represent our capacitance is equal to this one, so C is equal to Q divided by V, and the value of Q, or the value of charge, can be calculated by using this expression. So whereas we have a surface integration of epsilon vector of E dot vector of ds, so in this case the vector of ds is in Z cap direction, so ds will be equal to Z cap dx dy. When we replace all these components that we know inside this formula, then we will have this expression. Since the x multiplied by y can be represented by some value of area of A, so we can replace this expression by using this expression. So in this case, whereas the value of Q, or the expression that represent the value of Q, is equal to epsilon E multiplied by A, whereas this value of E is equal to amplitude for the electric field intensity. At the same time, the potential difference between the conductor can be calculated by using this formula, whereas minus integration from 0 until D, so this is the position of our conductor. So this is our vector of field intensity dot with dl. By replacing all the component that we know inside this expression, then we will have the potential difference is equal to minus integration from 0 until D Z cap E multiplied by Z cap dz. So by solving this expression, or this operation, we will have the expression that represent our potential difference is equal to E. So this one is the magnitude for the electric field intensity multiplied by D. So D is the thickness for the dielectric. So by replacing this expression and this expression inside the general expression for the capacitance, so we will have the equation, or the expression that represent our capacitance, is equal to epsilon A divided by D. So whereas this is our electric permittivity for the dielectric, so A is the surface area for the conductor, and the D is the thickness for the dielectric. For the second equation, so we need to find the breakdown voltage for our capacitor. Alright, so let's say the dielectric material we use this time is equal to quartz, and the EDS, or breakdown field, for quartz is equal to 30 megavolt per meter. So the breakdown voltage can be calculated by using this expression. So whereas VBR, which is represent the breakdown voltage, is equal to EDS dot D, and by replacing the value with the value that we know, so we can have the breakdown voltage for this particular capacitor is equal to 0.3 megavolt. Alright, so in order to demonstrate your understanding towards these topics, so please make this exercise. So let's consider a coaxial cable. So we have two conductors, the outer conductor and the inner conductor. A is represent the radius for the inner conductor, and B is represent the radius for the outer conductor. So the length of this conductor is equal to L, and the both conductor is connected by using a DC voltage as shown in this figure. So please find the expression for the capacitance per unit length for this coaxial cable. Alright, so you need to do this exercise by using your own handwriting. So write your name and matrix number in your answer. So scan it and submit through ULearn. Alright, so that's all for now. Should you have any further questions, so please do not hesitate to send that question or feedback in the ULearn. Alright, so that's all. Thank you.